Hello. This video is about applying coordinate geometry to quadrilaterals. So this is where our actual coordinate geometry comes into. All the previous videos were on the basic formulas and calculations that you must know. So now we're going to start applying this. Okay, in this example, you are given PQRS, which is a square. They tell you it's a square. And you are given the coordinate of P and of Q and of R. Okay, now for the first question, they ask you to find the coordinates of S. Right, now we need to go and look at this drawing. And remember, people, that's why I keep on telling you that you must do those drawings into your exercise books when you can. All right, so look at P and Q and look at R and S. We know that these two are parallel as well as of equal length. Okay, because they are parallel, people, they will have the same gradient. So we will work with a gradient. Right, now what you're going to do, and I think that is the easiest way to explain. If we look at the gradient, which is the y change, okay, that is the y change over the x change, which is the x change, then we can basically count the change itself, okay? So from here, it's 1, 2, 3, 4, 5, 6. It is 6 units, right? And then from here to Q, it is 2 units, okay? Now, because we count downwards, we will make that -6 and we will make that +2, right? Now, that is the same for RS. So let's draw the same triangle onto RS. Okay, sorry, this is R and this is S. We know that this is 6 units and we know that this is 2 units because it's the same triangle that we have drawn. So when you now go and look, I'm going to just take it a bit further. For the x value, all right, for the x value, look here, R, you have 8, okay, and we are moving basically 2 to the left, okay. In this case, you move 2 to the left, so this becomes -2. So to find S, people, we go from 8, do you see that? There's 8. Okay, and you move 2 to the left, so therefore it is 8 minus 2, which equals 6. If you look at the y values, right, the y value here is 3, right, and to go up to S, we go up 1, 2, 3, 4, 5, 6. So we go upwards, meaning it's going to be added. So the value of the y here is 3. It's 3, and you add 6, therefore that will be 9. So the coordinate for S is 6, 9. And as soon as you have calculated something, I always suggest to write it into your drawing because it is easier to then find following questions. Okay, then the second question here is to find the equation of PQ. Now remember, to find the equation of PQ, look at what we have. We have 2 coordinates, right? And when we have 2 coordinates, people, we first need to find the gradient. That you must remember. To find an equation, we are working with y equals mx plus c. Okay, so to find the equation, you must have the gradient and you must have c. Otherwise, you can't find the equation. So in this case, simply write down your coordinates P and Q and calculate your gradient. Your gradient, people, remember, is y change over x change. So we learned that we would label x1, y1, x2, y2, and then to get the change in y, you must subtract actually 7 minus y. Well, I turned it around. I did y to 1 minus 7. Okay, and then to get the x change, you must do it in the same sequence. You must also start with 2 minus 0. Okay, and if you then calculate this, which is 1 minus 7 over 2 minus 0, you get negative 3. So in step 1, as I taught you, you substitute the gradient m with what you have calculated, which is negative 3. Okay. Then in step 2, you are now going to substitute the values of one of these coordinates. I have chosen the values for q. So in place of y, you write the 1. And then in place of x, you write the 2. Okay. You can also choose p. It doesn't matter. It will give you the same answer. So in step 2, you replace the y and the x to find c. Can you see that this is the only variable now? Then you calculate this and you will get c being 7. Okay, and then in the last step, step 3, I told you, you just put your answers into the formula. You have calculated m, you have calculated c, so put those values in and you've got your equation. All right, and then the next question asks you to calculate the area for the square. Now, obviously, people, you must know the formula for the area of a square, which is side times side, which means you must have the side length, okay? And now, if you look back at this one, people, okay, let me I just forgot to enter this value. The equation for PQ is y equals 3x plus 7, right? We've got P, we've got Q, we've got the equation, but we don't have the side length. All right, but we have a formula to calculate the side length, which comes from Pythagoras. Remember this formula? The side length of PQ, I'm going to work with PQ now. It does not matter. You can work with either one of these lines, but you must get the side length of one of the sides. Is x2 minus x square root of x2 minus x1 squared plus y2 minus y1 squared. Right. So again, people, let's look at P and Q. This is where I've written that down. So x2 and x1, I turned this around now, is 0 minus 2 squared, which gives you 4. Okay, and then for y2 minus y1 is 7 minus 1 squared, which gives you 36. And when we calculate that, our length for PQ is the square root of 40. You will now not take the square root, people, because you still need to do the area calculation. So now one side is the square root of 40 times the second side, which is also the square root of 40. And when you calculate that, you will actually get an answer of 40 units. Right, so this is a bit more difficult. I can just suggest people to always make a drawing of what is given. All right, and then remember, you must know all your basic formulas for coordinate geometry. So that will then actually give you the idea what you need to use. All right, otherwise you don't even know where you must start. So please learn all the formulas for your coordinate geometry.